All right, class. Today we get to talk about one of my uh, favorite or interesting topics, and that is random number generation. Now, if you ever played any any game at all, pretty much, whether it's like a casino, whether it's a video game, you get to deal with random number generation. Now, what random number generation is where the computer randomly picks a number between a certain range. There's a bunch of different ways to do this. Java has a couple of ways to do it as well. We'll go through that and how that works, and talk a little bit about what it's used for. Uh, let's use an example first. We'll use a real world example and then we'll use a game example. Games are probably the easiest to pull from. But if we look at, let's say, a video game where you swing a sword and you hit somebody, the sword has a certain amount of damage to it. You probably have stats. There's probably some complicated math formula that determines how much damage you're going to do, whether you're going to hit or not, and there's some percentages involved there. So let's say I have a 10% chance to miss. Well, if I had a random number generator that gave me a number between 1 and 10, if I picked 1, I missed. If I picked any other number, I hit. That's how that would work. Damage, maybe if I hit him, whatever the little critter happens to be, the damage of the weapon can be like, let's say, 10 damage, right? But it's not always 10 in most of these games. It's usually a range, somewhere between 7 and 13. Maybe you have a chance to do twice as much. Uh, all of that is just random number generation. The same would be true as if you kill something and it's going to drop a prize or something like that. Uh, Many a person has been, basically knocked over by RNG. Uh, the random number generation gods have looked down on you and shook their heads. There's a 1% chance for this thing to drop. You kill 100 things and you don't get it. You kill 1,000 things and you don't get it. It is 1% chance. Then if you kill 100 things, you should at least get one, typically. It doesn't always work out that way. Because a lot of times it's 100% or 1% chance every single time you do it. Uh, Sometimes the math doesn't actually turn out to be, you know, as simple as you think. Now, if we're talking about casinos, there's another place where random number generation is used. Every time you go to, let's say, a slot machine, you pull down the lever. The slot machines themselves, are programmed to basically, pick a random number. Are you going to win? Or are you going to lose? How much are you going to win? The second you press the button, the second you pull the lever, it knows whether you've won or not. The little spinning reels and stuff, it's just for show. Instantly, you press that button, it knows what the prize is. It knows whether you won or lost. Now, the trick to casinos, though, is they're kind of a weighted random number generation. So basically, what that means is it's not completely random. If you check any casino statistics or anything like that, it's like basically, they'll say they pay back 90 something odd percent of what they take in. And if you think about that, well, they pay back 95%. That means if you go in there with $1, you're going to come out with, on average 95 cents, which basically means that a casino is designed for you to lose. Now, of course, it doesn't work that way always. It's more distributed. You might have three people who go in. One person loses everything. Another person makes $5. Another person loses $5. Another person wins fairly sizably. And then, the casino keeps the rest. That's pretty much how it works. But all this is based on random numbers. At least, that's weighted, but random number generation nonetheless. Now, if you're looking at card games or dice or things like that, that's a little different. Unless you're talking about a computerized version of it. Then you're back to random number generation. The actual physical cards, though, aren't random. But if you want to represent them in a program, then they probably would be. So let's talk about how Java deals with random number generation. I'll explain it kind of step by step, and the two or so methods you could use to get some random numbers and where it comes from. So you can go ahead and put the date. In this case, that's today's date or tomorrow's date or whenever. Whatever the day's date is, put it in there. And call it, random numbers. At least make sure it's saved, finish. All right, now there are two ways to deal with random number generation. Ba-da-ba, there we go. Now I prefer what I would say actually of the two ways, I prefer one of them more than the other. You can technically consider it kind of the long way because the line you're writing is a little bit longer, but there are less lines, and it just makes more sense to me. So I'm going to do the long way first, or I guess you can say the more manual way. And then I'll show you another way where we can import something and use that. But honestly, when you look at the two of them and you know how it works, there's almost really no difference between the two for the most part. It really just depends on what you prefer. But I'm going to go ahead and start. Now, first, I'm going to just write an integer, and I'm going to write out this long line that's going to give me a random number, and we're going to print it, and I'm going to show you. And then I'm going to break it down into parts and show you how we're getting that random number. And then we'll go from there. So just follow along for now. So we'll start with that, and I'll just print off. And I'll take a quick look at the bottom here. So I run it, you'll see I get a 0, I get a 4, 2, 6, 7. Every time I run this, I'll get a number. Now my number range is actually between 0 and 9. So let's explain what's happening here. First off, math.random. This right here gets you a number between 0 and 1, a decimal number. So in this case, if I were to say, R1A equals math.random, and I just print off R1A is plus R1A. And I run it, you'll see I get this random number between 0 and 1. It's always a decimal place between 0 and 1. It's never going to be 0, it's never going to be 1. It's just going to be somewhere in between. That's what math.random does. It's kind of a built-in Java function. Now, it does a bunch of funky math to figure this out, and it pretty much uses what's called a seed value. Anyone who's played, let's say, Minecraft, for example, you create a world and it randomly creates the world around you. But it also allows you to put in a value. So basically, you can recreate the same world, if you wanted to do this, have basically the exact same world you had before. And it does that because of that little seed value. It plugs that value in. Let's just say if I was doing a simple math, 2 times 5. And 5 is the value I'm plugging in. I get 10, right? So if I plug in 5 again, I'm going to get the same value, more or less. What this is using is actually the system clock. Now I think, I don't remember if I've talked about it or not, but there is I will mention it eventually if I haven't already. But the system clock on your computer goes in milliseconds. And there's actually I think I did mention this when I went over the long, for example. Long num equals, and it would be system.currentTime millis. Now, what that does gives me the number of milliseconds that have occurred between now and, like, I think I said 1970, January 1st, something like that. And you'll see it changes. 1,000 milliseconds is 1 second. 2, 3, 4, 5. You see that? And it uses that value as the seed for this random number. Now what this means is every time I run this, I can get a different random number, potentially. I mean, I could get the same depending if it's a small range, but you kind of see if I had millions of numbers to pick from, it would be hard to hit the same one easily. It's not impossible, but just more difficult. So it uses this constantly shifting number to basically give you your random number. Now, boop, there you go. Comment that out for now. Now the thing about the random number generator is it is evenly distributed because of how it works. That means I have an equal chance in this case to get 0 as I do to get 9. Let's say I wanted to do, dice 2 to 12. In a real game of dice, what percentage chance do I have to roll a 2? What percentage chance do I have to roll, a 7 or 8 or something like that? You actually, and craps, a casino game, is actually built around this idea. 2 and 12 are the least likely to roll because there's only one possible combination of dice, of 2 dice, that will give you that. If I'm trying to roll for a 2, I have to have a 1 and a 1. Each of these have 6 sides. There's 6 possibilities on one, there's 6 possibilities on the other. So there's one possible way out of, I think, 36, if I'm not mistaken, possible outcomes. So 1 out of 36 to get a 2, 1 out of 36 to get a 12. They're just that rare. 7 tends to be the most. You can have a 2 and a 5, a 1 and a 6, a 3 and a 4. And you can flip it around and have the same numbers on the other direction. So there's about 6 possibilities there. So it's much more likely to get a 7 than it is to get a 2 or a 12. Now, if I'm using this random number generator, and this is where I'm getting it, what I'm getting at, there's an even chance to get everything. So if you wanted this to follow, let's say, the rules of dice, you were building a game where dice were involved, you wouldn't want to use this random number generator by itself because, well, you want it to follow just like a real world game. You don't want it to be, oh, you could roll a 12 3 times in a row. That probably won't happen in real life. It's not impossible. And actually, I've personally done this before. It was during a game of Risk. Someone was invading my Australia. I always took Australia. And they come in with this massive army. I rolled 12 3 times in a row. Said, get out of here. Wreck them. I still lost the game, I think. But, that was an epic moment. And the odds of that happening, 1 out of 36, 1 out of 36, 1 out of 36, really infinitesimal. Probably will never happen to me ever again. I'm ashamed that I used my luck on that one thing when I could have used it on the lottery or, anywhere else really. But, well, it happens. But my point is, if you wanted a realistic dice game, you'd have to adjust it a little bit. Uh, you know, I'd have to maybe, let's say, get a number between 1 and 36. If it was 1, it would be that 2. If it was, 36, it would be the 12 or something like that. I'd have to weigh it a little bit. There's several different ways to do it better than I just explained it, but you kind of hopefully get the idea. Now for us, we don't have to worry about that for now. We're just trying to make random numbers. Now, the random number here gives me 0 to 1. That's the first stage, which is this part here. You'll see there's a lot of little parentheses. Now, what happens is it's going to do that, and then I'm going to multiply it by 10. So what happens to this number? If we take a look at it, when I multiply it by 10? Well, it moves that decimal place over. Now it's 8.6. So that's the next step. So I would say, in this case, double R1B equals R1A times 10. And I'll just print that out. R1B is plus R1B, and you'll see a quick little run. 0.27 is now 2.7. Now, The last part of this, and basically whatever I multiply this by, if I multiply it by 10, it will give me a range of 0 to 9. So, you know, times 10, 0 to 9. If I multiplied it by 100, it would be 0. It's always going to be 0 to 99. Basically, it'll be 0 to 1 less than what this is. So if I were to multiply it by, let's just say, 47, that would be, I'll give you a chance to think about it, it would be 0 to 46. So it's always going to be 0, and we'll talk about how we can tweak that first result there in just a minute once we get this done. But we've got this second option here. We've multiplied it by 10. We've moved this over. So the last part is this. This is what's called a cast. Basically, I'm forcing the number to be an integer. Now, if I force this to be an integer, a lot of people will look at this and say, well, it's going to round up to 3. No. Forcing this to be an integer is basically taking a knife to it and cutting off anything that's not an integer. Basically, I would just slice off everything after that decimal place. So even though this is 2.7, in the end, it's going to be a 2. It's not going to round up. So basically, this last little part here, int r1c equals int r1b. And I can take the parentheses off there. It doesn't really matter. And I'll just say, I know it looks like an L. L and 1 look pretty similar when you type them out, but it's a 1. It really doesn't matter what you write it as, but as long as it's there at the end. R1c is plus R1c. So we take a quick look, and you'll see it is 2. Right, it gave me pretty much the same number. I run it again, 2. And now we're 0.84. We go up to 84, we cut off the excess, we end up with 8. That's how it ends up with that number, 0 to 9. Now at best, this number, since it's never going to be 1, will be 0.99999, which would basically be a 9. I multiply it by 10. If it's 0.000, well then it will give me a 0 if I multiply by 10. So that's how we get this 0 to 10, or 0 to 9 in this case. Now, most people are probably thinking, well, if it's always 0, how do you make the minimum number work? Well, if I want the minimum number to be bigger than a 0, for example, well, there's a simple change I have to make. And as I said, this right here is what I prefer. And I'll show you the other way here momentarily, but let's say I just paste that and make a second rand. 2. Let's say I want this to be 2 to 12, like the dice we were talking about. Well, here's what I have to do. It actually involves a little bit of math. Now, times 10 will give me 0 to 9, right? I want this to be 2 to 12. So the minimum number is going to basically always be a plus at the end, plus 2. So basically it means if this is 0, if this whole statement equates to 0, then I'm going to add 2 to it. 2, and then it's going to be 2. If it ends up being 9, this would push it up to 11. Now, since I want it to be 2 to 12, I have to figure out, well, what do I have to multiply to get 10? I'm going to subtract 2 here. Well, what do I multiply to get 0 to 10? Well, it would be 11. So if I do the math here, this will give me 0 to 10. And if I add 2 to both of those sides, 2 plus 0 is 2. 2 plus 10 is 12. That's how you adjust the minimum number. But the plus adjusts both sides. So to give you a little example of how I do it, a lot of people tend to have some trouble with this, but I'll bring open a little paint here maybe and show you here. So let's explain a little bit. Let's say I want, in this case, let's pick a number, 20, pardon my writing, to 43, right? Let's say I have a weapon equipped or something, and that's the damage range it's going to give me, 20 to 43. Well, first off, here's what I'm going to do. And it takes a little bit of algebra, but it's really not that hard. I will say, okay, I'm going to subtract 20 from both sides. Oh, and actually, let me see here if I can do this. All right, so I will have this, int math.random times. And I guess I need to make that a little bigger. Boop. Plus. Doop, 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 doop. Now, the blanks here. This one is basically what the multiplication is going to be. This is what the addition is going to be. So if I come up here and I subtract 20 from both sides, minus 20, minus 20, I'll get 0 to 23. Now, the number I'm going to add at the end will be this number that I'm subtracting. So that's going to be the plus. Whatever the minimum number is, that's the plus. 20. Cute. Not quite as pretty as I'd like, but yeah, you kind of get the idea, I hope. There, 20. Now, what do I have to multiply to get 23? 0 to 23. Well, if I multiply by 10, I get 0 to 9, right? If I multiply by 23, I get 0 to 22. So basically, you just simply have to add 1 to that. And that's what I got to multiply by. 24 in this case. So I would do 24. And you could try this a couple of times. Do a couple of numbers, a couple of number ranges. 500 to, 893. Well, if 500 is the minimum, then 500 goes here. You subtract, there we go. Let me grab a something you can see up here, perhaps. Pencil, there we go. That would be plus 500, and you would subtract it, and that would leave you, 383. Well, what would go there would be 384. You just add 1 to that. It's actually fairly simple math, but for some people it does take a little bit of practice for that. Now, that is how to get a minimum number. And again, for extra practice, just try a couple of numbers. And if I run this a couple of times, and I'll print rand2, we can test it. 8. There's a 10. I should go down to no lower than 2 and no higher than 12. I run this enough times, there's a 12. I don't see a 1 or a 0 yet. There's 2. And if you run this, let's say, there's 2 to 12, 10 different numbers. I run this 20 or 30 times. I should see one of those numbers. Oop. There you go, an extra. There you go. Try changing out a couple of numbers. Try doing a little bit of math and seeing if you can get within a range that you'd like. It just takes a little bit of practice, and it's really not that hard. Now, this is the way I typically do it, because it's just one line of code, and I just have to plug in the numbers. Now, the other way you can do this is to import java dot math dot random, is it? I'm trying to remember. I don't use it that much. Java dot, there it is, random. Pop. I think that's it. I may have to look it up just to make sure. In retrospect, it would have been a good idea to do that before, but, here we go. We're here already, so So let's take a little uh, contemplation here. Uh, I basically it's kind of like a scanner. Random R1 equals new random. I have to basically just have this line here. And now I can use the random generator. And this is what puts me off to it. I have to have an import at the top. I have to have this line here. And then I can use the random number generator. Int rand3 equals r1 dot next int. And I can say 10. And what that's going to give me is whoop, rand3. I think most people tend to agree with me here. Uh, that'll give me 0 to 9. Run it several times, and you'll see. But I have to write 3 lines of code for this to work when I just have to write the one kind of lengthy one for the other. And of course, if I want to, do 2 to 12, I do a little +2 there, and 11, and I get the same thing. It's basically the same thing, as you can see. If you prefer it, I mean, that's up to you. It's r1.nextInt. If I wanted a random double, I could do that too, but this is generally how I prefer it, personally, just because it's one line of code whenever I need a random number generator. If you prefer just to do this, if you just like that one line, and really it's not that much shorter, but there are some people who just prefer it. Pick and choose. Doesn't really matter which one you pick. But you will have to have these 3 lines of code, or these 2 lines of code first before that works. If I don't declare my random number generator like I do with the scanner, then I get an error. If I don't import it, then I get an error because it won't know what the random is. The math.random is built in, so basically you can just automatically use it. It has far less issues for me, but I've gotten used to it. If you prefer one or the other, play with both. See what you like. And actually, you can later on we'll create our own like program that we can plug in a minimum number, a maximum number. It'll do all the math for us. That's not a possibility. I usually do that in Java 2 in particular. And all we have to do is basically just say, I want a 2 and a 5, and it'll do the subtraction for us and automatically do it. Most games, some of their foundations are built on random number generators. And they may not just use the built-in one, they may create their own. Depends on what they need. For us, you know, Java's got 2 built-in ones that are, and honestly, this just uses math.random. It just kind of abstracts it a little bit so you don't see it. But I mean, it's going to work for anything we need at the moment. It does have its issues, of course, but there are ways around anything, pretty much. Now, if you have any questions or issues, just be sure to let me know. Comments, whatever you want. Hopefully this enlightened you a little bit in how Java does its random number generation and some of the problems you can run into in that. But it really does open up a whole new, you know, avenue of things you can do. Have your program randomly generate things. There's tons of random generation in pretty much every game program you can think of. There has to be something. From random number generation in levels. If you've ever played Spore, for example, it's an older game. Surprised saying that, but it randomly generates a bunch of stuff. Minecraft randomly generates the world. There's randomly generated music generators, which are kind of interesting. It just, randomly generates what instruments it's going to play, what beats are going to be played. If you want some fun, just type in random MIDI, MIDI generator, I think. And voila. You might have a little bit of fun tweaking and playing with those because it'll randomly give you songs and things to listen to. It's kind of interesting. Not so much as like, well, I mean, even let's say iTunes or some of these random radio apps and stuff work kind of the same way. They have a repository of songs and it randomly picks a number and plays one. It works by the same basis because random number generators are used everywhere for pretty much anything you can think of. So again, questions, feel free to ask. Otherwise, I will see you next time.